Good evening. Welcome to the first East End Seaport Museum and Marine Foundation lecture for 2023. We plan to have all through the winter series of lectures. They are listed on our website. Hopefully there'll be some more that I can sneak in there, but as of now, we have a pretty good smattering from all the way from weather to fish telemetry, and I believe we actually have one on seaweed too. That's just, I'm pretty excited about this. Well, anyway, tonight, Commander, I like that, Frederick Smith will be hosting a lecture on how to read weather. This series is in this seminar is in 3 parts. There'll be an introduction, and then there's 3 parts. They start from a more global view and work down to the small, all the way down to what you need to know on the water. Without further ado, oh, by the way, my name is Paul Creeling. I am chairman and curator of this fine establishment. Fred, take it away.
Good evening. Thank you, Paul, for including us in this program. It's great to be kicking it off. We're pleased to do this particular seminar. It's really a mini seminar, but by way of introduction, we're the United States Power Squadrons. We are America's Boating Club, and we're Peconic Bay. Peconic Bay we cover from Orient Point around to Montauk Point. Give you an idea of who we are. Education is one of our major goals and major programs. Whether it's an online course at your own pace, classroom with certified instructors, or virtual and a mix between live and virtual. And then most important, we're able to offer hands-on training and skill development on the water. In our boats, in your boats, that's the important thing. That's where we can make a difference. And lots of courses, boating education. Now on the bottom list there, you'll see a weather course. That is an 8 to 10 week course, 2 hours a night. So you can imagine that the little smattering we're going to do in an hour will just be enough to cover the highlights.
Fred, where can you get these books and how can you sign up?
Well, we can do it through Peconic Bay Power Squadron, or you can, if you're doing online programs, through United States Power Squadrons, usps.org. Or go to America's Boating Club. We'll show that at the end. But Peconic Bay Power Squadron, our own website is pbps.us. Simple as that. And you'll get a million links from there to education, maternal, et cetera, et cetera. So as you can see, there are a lot of different seminars. We're very high on marine environment, boat handling, et cetera, et cetera. So that's who we are. That is a good website to go to, again, to get all the information you need and get all the links, a lot of tutorials. Also, if you go on to the Apple App Store and go to America's Boating Club, you can download a free app. You'll also have on that app all things about boats and boating, but also it'll cover weather, boating conditions. So it might be a helpful tool for you. So tonight we're together to touch on how to read the weather. Now, this particular mini seminar was produced for the boat show. Last did this in Maritime Festival, actually at the museum in September of 2019. But it was actually produced for the Newport boat show that was done in September 2018, among a few others. We'd like to thank NOAA for their help in supplying some of the information. They're a good support to us for our educational work, and we continue to work together with many of the different services. So in past eras, we had many of the sailors who knew how to read the weather, or at least they thought they did. What they found was that some of their information didn't quite work out, but these are 4 pretty good shots at how to look at the weather and come up with a little saying to go along with it. As we work through this evening, these will all be pointed out. But for instance, at the bottom, when the glass falls low, look for a blow. That's going to refer to our mercury barometer.
Hey, Fred, does red sky in the morning, sailors take warning, have any fit into that category?
Well, it did more in the past. Now I think with all of the contaminants in the air, you're more likely to have a red morning or a red night. But there was some validity to it, but not enough to earn our place on the list tonight.
All right.
So our topics tonight, we're going to start with fundamentals. It's a way to get a handle on it. Then we're going to go into seeing how storms develop and affect our lives. And then onboard observations for a quick look, a short window to check on what's going on around us. So weather fundamentals, global heating, we'll see that, which will in there cover and form air masses. We're going to deal with humidity and how winds affect so much of all of the weather that we have every day. So what causes weather? The sun causes weather. The sun's heat, their radiation power, that is what starts the ball rolling. And when it hits the earth, the uneven heating will lead us to changes between heat, hot air, and cold air. And the difference between those 2 zones will mean that there'll be movement. There'll always be movement from hot to cold, from highs to lows. Now, as we can see, we have a great deal of water on the earth. We have ice caps, we have forests, and first land will heat more quickly. They'll be hotter and colder than water. There's a big difference between how the 2 warm and how the 2 can reflect the light and the energy back. So reflection, clouds and ice will actually reflect back between 75 and 90% of the energy that the sun is sharing with us here on Earth. Forest is only 3 to 5%, and sand anywhere from 15 to 45%. So it's really uneven. Now, one of the real concerns with our scientists today with global warming is the fact that the ice caps are melting. The glaciers in Alaska and the same in the southern hemisphere are being eroded. So what happens? That reflection is lost. It's now dirt, it's sand, which absorbs the sun's energy more, which warms the surrounding area, which causes the caps to melt further. So you can see it's in a cycle that's very difficult to deal with. So beside the fact that it's different types of surfaces, we have a different way that the sun hits our planet, particularly due to the 23-degree inclination. As we see in the first two circles, the sun's radiation is equal at that point. It is full power. Where we see a change is when we, one, see it at the equator, where it's still the most intense, and second, as it spreads over the polar regions. Now, once it spreads in this way, the power is lost quite a bit. So not only do we only get sun up there a few hours a day, but at the same time, the sun that reaches, the power that reaches, the radiation that reaches is a lot less strong. The tilt of the Earth is the other part of the process that makes a difference in heating. Now we've just completed last month our winter solstice. We are in winter and we had our shortest day. So not only is the sun hitting us less, but when it does hit us, it is for a less period of time. Equal during the autumn equinox and the vernal, and then summer, where we can enjoy longer days and warmer days. This is taking a look at Newport, and it's not that much different for Greenport, for that matter. But we can see that we're 72 degrees high in the sky and long days, 49 and 12, and now in the winter, 25 degrees high and only 9 hours of sun. So there is quite a difference. So due to all of this heating, we're going to wind up seeing different parts of the globe, and we're looking at, for us, North America. And we have Arctic with a capital A, cold, very frigid and dry. Polar, cold, cool, maritime, over the water, continental, drier, here's wetter. As we drop down, we have tropic, over the waters, hot and wet. As we come into continental, this would be the deserts, and at the 30 degrees, deserts across the entire globe will be found in this general area. These warmer areas, tropic, are all below the polar front. The cold is above, the warmth is below. So we're going to take a look at how we proceed and when we would get these frontal movements. Let me just go back and say that each of these masses, air masses, winds up taking on the same characteristics as the Earth below them, so that this is wet over water, this is dry over the deserts, et cetera, but they're not stationary. They're going to be moving. They're going to be moving due to air, due to the winds. So as they move, and we'll look to New England, which gets a lot of weather, a lot of changes. So now we have the cold winter air, dry and cold from the continental polar. During the summer, wet, warm weather coming up from the south. Luckily, a few days of the year, we can even enjoy the hot desert type, dry, hot air. We look here, we're getting air from the North Atlantic, from the Northeast. And this is, in fact, called a backdoor front because it comes in opposite of what we might expect. And then the very cold Arctic air, and we'll see at what point that will be able to force its way in and really deliver cold and frigid weather. So Boston, as we said, New England gets a lot of changes. So this is a polar front. This isn't the jet stream, though that is how it would be shown on your weather channels, et cetera, but this is the front itself. So we have the very cold air above, and in this case, we've had the warm tropic air come up in 86 degrees at Easter. 2 days later, this front has been pushed down, driving the warm air back, and now our temperature and dew points are dramatically lower. It doesn't take much time for a front to come through. And we've seen this over the last days in December. It was very cold. So one of the other things that is going to bring us weather, and precipitation in particular, is measured by the dew point. It's when the droplets will condense, vapor will come into droplets, we'll have crystals, we can develop fog, etc., and frost. Now we're going to find that when our temperature equals the dew point, our relative humidity would be 100%. So many times we'll use relative humidity rather than dew point, but dew point is a way to measure this humidity. We can see here that we have a spread between the air temperature and the dew point. So the smaller the spread, as they say, the higher chance of fog. It just means that we're getting closer to 100% humidity, and that's when our fog and clouds, etc., will form.
Fred, how do they measure dew point?
Dew point is measured, let me go back, in this case, with a barometer they're going to use. There are a few different, an anemometer that can be used. And in this case, we're going to use a barometer.
Okay.
So we'll be able to take both dew point and air temperature at the same time.
Thank you.
So now we have different types of fog that is caused by the humidity and by changes in temperature. So in this fog, radiation fog, we have cold air coming in. This can be on land or water, but it's normally a land fog. And cold air will be coming across and cooling the air just above the ground, and it'll cause this radiation fog. This, as soon as we get the day to warm up or a breeze to come through, it would dissipate. Convection is different. This is over water, where we have warm air coming across the cool water. We can see this in ponds and lakes, and if it's cool enough, even
There is a boat in there, right? There is a boat in there, right?
it's there somewhere. So that's the evection.
Hey, Fred, your volume's gone down a bit.
And that's the evection fog, and that'll dissipate if we get a little more temperature, get a little breeze. Sea smoke, this is, again, warm air coming across the very cold waters. Lots of times in ponds and lakes, but if it's cold enough, even over the waters of the bays, etc. And precipitation fog is the leading edge of a front where we're going to start having rain, and the rain has started to move in and form dew and crystals. And this is actually, like as with most other fogs, it's just simply a cloud that is just on the ground. And this will clear when the wind picks up or change direction. So this is what we need to do. This shows a fog bank coming in. It means poor visibility. And these are the things that we need to be aware of when we're on our vessels. So let's see how the air moves. What we have here is a convection cell. We're very used to this phenomenon here on the island. In the summer, as we move out and look at the bays, we're going to find that as the land heats up late in the morning, by noontime certainly, the air is going to travel from high to low, from cold to warm. And the air will come along cooler and it starts to warm. As it warms, it's drawn up. Hot air will rise. It'll rise to a point where it starts to cool off enough so that it travels back, following to get to the high again, and the cell completes itself. This will happen until something changes. It's certainly not going to be that the water is going to be that much warmer. What is going to change it is that later in the afternoon, this warm land will cool off. And by nighttime, we'll have a land breeze, which is the reverse. The land breeze, everything reverses, and we will wind up getting the warmer air from the colder air on the land, moving onto the water, moving up the heat and across. So it's just the opposite.
So that's why they call it evening, huh?
It could be. Well, that was just a sea breeze, but the same effect is noted on a global circulation, a global scale. We learned early on that the equator is the warmest spot, and we will wind up heating here. The heat will rise, and will try to make its way to the polar high. We will find in this case that some of it makes it all the way, but some in the opposite, in the upper atmosphere, will cool, and it will come back down at around the 30-degree mark, both northern hemisphere and southern hemisphere. So let's take a look at just the northern hemisphere for a closer view. So we can see as this comes through and comes down at 30, which happens to be where the deserts are, etc. So it's warm, hot air, and this they've named the horse latitudes. Actually, in the days of the sailing ships, the square riggers, if they wound up in this section and they're trying to make their way, they can be calmed the winds are light and variable, and they actually had to jettison their horses to lighten the load and to save water until they can make it to the destination. So a lot is at stake at sea, and knowing where you are, your latitude for sailors would make the difference between a successful trip and perhaps being lost at sea. So we're talking about the movement of air from highs to lows, highs to lows. And on, we're going to see that we have a couple of areas. Out of this high into the low, this is going to be a northeast wind. That's by way of where the wind is coming from, not where the wind is going. So it's from the northeast. They're northeast trade winds. The prevailing westerlies, and we call them prevailing because they're not as consistent. There are more going up there with the polar low and fronts. So it's not as dependable as the trades. But they were both used, and we're going to see how the sailors of the past with their square riggers would use these routes to cross the Atlantic. So we have our sailors coming from Europe. They might very well have made their way down from England, down the Canaries, and now they would pick up that northern trade winds that would bring them all the way across into the Caribbean and Eastern Atlantic. They'll do their trading and whatever down here, and they'll start to make their way to prepare for their trip back on the westerlies, back to England. So in the mid-1500s, a port was set up in St. Augustine. This is where they would wind up refitting their ships, restocking, and then following the Gulf Stream up, since that is pushing in the right direction, and sailing until they could again cross back to their place of origin. So winds flow from high to low. That's going to be consistent. But in the Northern Hemisphere, due to the Coriolis effect, winds shift. And in highs, they're going to turn clockwise. In lows, they're going to cut counterclockwise. And as they spiral, they'll cross these isobars. The isobars are where all of the energy is the same for each. So with the low here, high here, the winds will change, and the winds will be most strong and fierce as these isobars are closer together. More energy will be spent. This gives an idea of surface winds. And there are many things that are affecting them, so they're not going to be quite as strong as the upper surface winds. But here we can see the winds coming along and traveling north and south, cooling breezes in the summer. Here we can see a great deal, looks like a nor'easter coming into New England. But all of these are predominant patterns. And this is what they look like as we move forward. Now, these are upper air winds. The upper winds are more consistent. There's less going on to disturb them. They're higher, obviously, and they're a lot faster. But the effect is the same. They're going to move around lows. They're going to wind up here. We're going to see what is a jet stream.
Fred, how is this information gathered? Is it because there seems to be patterns and things? When it changes, how do we know?
This could be measured by checking the satellite views. We can also, this will be done by measuring the speed, and also by measuring how fast the clouds and air masses that we're going to look at next have been moving. Obviously, you can't see air per se, but you can see what effect it's having on the winds or the weather around it. So here is the main, let's see. Here's the main jet stream. This is the effect of the polar high, or polar low rather, pushing down. And this is a tropical stream. That's a lot less strong, but it has the ability to carry weather across. This is what all of those things boil down to. These are the predominant tracking patterns for our North America. Some of them will not be used all year long. These two will be probably very north during the summer. They're all traveling from west to east. And then as they come over and they hit the Bermuda high winds, it's pushing things northeast and again up into the New England area. So that was the end of topic 1.
Are there any questions in the chat? Let me see if I can get the chat here. Any questions? So far, so good, Fred. You've been explained it clearly.
We will press on.
All right.
Well, here's our trusty barometer. This is a glass barometer that was actually produced in 1820 in London, and it was used on the British ships. Now, when a captain came to assume a role as a leader of his ship, the captain of his ship, he would bring his own barometer and he'd bring his own sextant. Those are the two things that would keep you safe and help you find your way on the water. So
they brought their clocks to their own clocks too sometimes. Yeah.
Yes. As time went further on and they were able to use a constant clock that was accurate, they were able to then discern where they were as far as longitude goes. Right. Latitude they could do early on, but longitude made them be able to truly navigate, brought them into the modern world, basically. So when the glass falls, we're going to get a low, we're going to get worse weather. When it's high, now it's a clear airs, and you can get out and have some fun and fly your kites. So how do these highs and lows work out? Well, as a low, everything wants to move toward the low. And the winds and the air approach and they bunch together. Well, here in this case for the low, they're not able to go into the earth. So they're pushed together and they're going to move up toward cooler air. And that's where the foul weather would be. Conversely, the high fair weather, this is warm air until it cools enough that it dissipates and comes down and it'll spread out on either side. So it's a matter of heating and cooling, just as we saw in the convection cell, where when the air warmed, it went up to the top, cooled off, made its way and came back down. Simply said, rising air cools, that's where we get our clouds and vapors, and eventually precipitation. Sinking air, it's warming now as we come down. We're going to get rid of these droplets, they'll evaporate, clear sky, no precipitation, and now you have a new high, just beautiful crystal weather. This will give you an idea of sinking air. This was Boston Commons the day after a magnificent blizzard. Everything is cleared out. The sinking air, the clear skies, no precipitation, just crystal blue with all this cold air left, cold snow left for us. So it's truly amazing how quickly these fronts can move through. And again, one day to the next, or not even that long, and the whole day will change. So how do we identify the boundaries between these air masses? If we look in our paper, we look on TV, they'll show these different symbols for cold air, the blue diamond, cold air, and this is usually much more strong and violent a change as a cold front comes through. This is a bullhead. It's pushing very strongly, and this is a warmer air that's moving up. You can see how sharply that has to move. And when those two come together, there's a lot of energy. Warm air is going to, or warmer air, is going to move up over the warm front until it later cools.
So that will form clouds right there.
They both form clouds as they go up. Yes. Here we're going to see that we have a cold front that's reached and touched with the warm front, so it's called occluded. And as they bunch together, it's almost the end of the cycle, and the warmer air is pushed up dramatically straight up. And we'll see how this looks as we move forward. We talked about where these come from and how they flow. And this is what a stationary front looks like. We have the polar front, which is easterly flow on top, very cold weather. Here is a warm front on the bottom. This is a westerly. This one, they're traveling parallel to one another. As they move, sooner or later, there's a disturbance. Something moves, the jet stream moves, but they start to develop an angle to it. They're going to start pushing against each other and the bulge will come up. So in this case, the frontal wave, the cold front is pushing and it's trying to get underneath the warm front and push that hot air above. As we develop and the storm is moving, now we can see this low is developed, and we'll have cool weather, warm weather, and precipitation, perhaps in front. And we can see that in this low, it's still counterclockwise until some of it escapes. As we get into a mature cell, the cold is still advancing, but it has caught up to the warm front here at the top, and now it's occluded. It is actually just pushing until there's no way that warm air in between can remain. So we have it up at our low. This would be the last before the cold front will totally push the warm front out. So how does this look? Here we have, back up. Here we have cold section, warm section, and a mix between the two with the magnificent low. And this is a traditional hook, question mark, exclamation point. And we can see that, yes. Okay, we can see that here. We can see where our low is from our satellite view. We can see the cold and the warm. And this is actually, we said a nor'easter that's coming in over New England. And this is how you could see it on the Weather Channel, for that matter. Just typical as we saw in our illustrations.
Now, Fred, this is a macro storm. Now, on a very small level, would that same comma thing form a tornado or some sort of local, that same principles?
All of the fronts, whether they're large or small, will react pretty much the same. You will not have it will not show up as dramatically because the energy won't be as much. So you won't have this much of a occluded front, but nonetheless, the cold will push the warm out of the way. Sometimes there'll be quite a lot of, you can see quite a lot of distance apart, but you can have some smaller storms that come through that will react very much the same. So this was a nor'easter, as we said, tracked off of New England, heavy precipitation, and we are not immune to nor'easters. Here on the island, we get a lot of them that would have come from New England. And as you know, some of them can be even more destructive than hurricanes for our particular location, because it doesn't cross the island as a hurricane might. It comes the length of the island from the northeast, so it travels and touches land and affects us with the rough waters a lot more than a quick hurricane could do. So along with these cold fronts, particularly at the front, the face of the cold front, that's where our clouds would go and start, and it's very possible that we would develop a thunderstorm. So a thunderstorm, we can see, will have three different stages. This is forming the cloud, and all of this warm air is rising, and it's filling up and the moisture is coming up into the cloud. In the second stage, mature stage, we still have a lot of energy coming back up. It's being fed dramatically. But we're also seeing that at the face of it, the air is so saturated that we have either rain or snow or whatever. And at the same time, the air is cooled, so it will start to fall again and down with the rain. In the final stage, it's starting to dissipate. So we're getting very little flow up to keep it alive. But in this case, we have more and a broader span of rain. And here we'll see an anvil top. Now these can last for maybe an hour, some less, some a half an hour, but they're all individual cells. So you'll have this same sequence follow behind until the air is given up its moisture, the wind switch or whatever. So let's see what this looks like. So here's our wind pushing us. And again, we could have had another similar cluster storm cell ahead, and we certainly can have some behind, but this is as it was growing, matured until it dissipates. Here is an anvil top, and a lot of energy has gone through. So again, it could be a short duration, but there'll be a number of cells that will follow through.
Oh boy.
Oh yeah. This is a massive front. And this is a very powerful thunderstorm. You'll have shear winds that come before it. Very dangerous. Very likely you can lose your electronics or anything of that nature. It is not a really good place to be. Okay. So.
Well, that was the end of 2. Now, any questions on that second bit of that forming of storms? Very well-behaved group. All right, let's move.
Let's say with the forming, just to conclude with that, the forming of storms, there are a lot of different things going on, and the amount of rain and snow and things of that nature that we can have, a lot of it is due to elevation, the elevation of the mountains around us. Here on Long Island, we're very protected. It's a very safe place. Very few hurricanes, a few nor'easters. Most of the heavy snow is to the north of 95, and La Nina is once again in control in the Pacific this year. This is the 3rd year in a row, which the forecasters indicate we'll have a warmer winter, and they feel that most of the snow will be above the 95 corridor. So all day long, summer or winter, we can look over the sound, we can look to the north, and we can see all of those gigantic clouds over Connecticut with their elevation. And before that storm can get to us, a lot of that precipitation is gone. So now we want to make sure that since we have a long-term view, that we look on board for a shorter view, something the same day, the afternoon. So let's see what this looks like. There are a lot of different reports that we can get One of my favorites is the NOAA with the VHF radio while I'm on the water, or even while I'm preparing to go on the water. On the East Coast, our closest is, we're lucky we have our own broadcast out of Riverhead. It comes out of, it comes out of Riverhead, and it covers specifically Gardner's Bay and Peconic Bays. And we've only had this for the last 5 or 6 years. So at Brookhaven is the central point, but we'll have one at a Riverhead for us. The same, they will have one for Eastern Long Island Sound. So we're covered, whether it's the Sound or in the Peconics, et cetera, and they can be dramatically different. So it's a good planning tool. It's certainly good while you're on the water. You'll also get weather alerts on 16 or 22A. If things are bad enough, the Coast Guard will give that type of broadcast. But there are so many different places these days to find out information, whether it's an app on your phone, where you can actually watch a storm come by. We can have a radar view, TV, cellular, radio. There isn't a reason not to be aware of what's going on before you venture out onto the water. So again, this is going to give us a short-term forecast so that we can be sure of what is imminently going to affect us. Whether it can be as simple as looking to the west and seeing the large black clouds of a thunderstorm heading our way over the bays on a summer afternoon, or being sure that it's supposed to be sunny and bright, but we're in the middle of a rainstorm. There must be something wrong. So it's to supplement or confirm what the professional forecasters have thought. Okay. So they're also going to give us, and there are many places to find this, a Beaufort scale. This is a way of identifying the sea states. And again, it goes from very light to violent storms at 12, 11. 12 is a hurricane. And this you can find with some of the reports. They'll give you the force scale. So this will be a 0, just flat as a pancake. Beautiful day. Perhaps not for sailors, but for power boaters anyway. Force 5, we're up there, we're starting to get 6-inch swells. Now, force 8, we have white caps on the top. Force mains. Force 12 is a dead-on hurricane. It's good informational if you want to identify the problems that you could find on the water, and in some cases just an interesting reference. So now we have our different types of clouds. Now, not all clouds mean rain. We're going to certainly find that out. And it's broken into 3 different sections plus vertical clouds. I'm just going to say that the cirrus, which would be the horse mane, just sunny day clouds. Cirrus, you will still see the sun through it or the moon through it. Cumulus, cirrocumulus, broken up. Mackerel sky, fair weather. None of these have any moisture in it that's going to affect us. So whether we're able to identify it or just enjoy looking at them, they are not going to rain on our parade. As we get into the middle sections, now these get a little thicker. Some of them will have some moisture in them, but again, it's not going to lead us to precipitation. More soft altocumulus, thinner clouds, still fair weather clouds. But now we get into the areas where we can pick up some that have some moisture in them. Strato is still not going to rain on us. Cumulus is still not going to rain on us. It can be a low weather cloud that will come up during the morning, the afternoon, and just dissipate. The beast of them all is the nimbostratus. This is the cloud, and we'll see big and dark, and this is responsible for most of the rains, snow, all the bad weather that we're going to have, all the precipitation that we're going to have. Heavy and long lasting. The stratus, they can have some precipitation in it, but it'll generally be light because it's a rather thin cloud. It just doesn't have that much depth to hold on to some moisture. The last section, and we'll see more, this is the vertical cloud. This is the cumulonimbus, and this is our hurricane cloud, our thunderstorm cloud. This can build to 40,000, 50,000 feet, and it can reach 20, 30,000 feet within 15 minutes. And within the half hour or so, you can have your full storm. And we saw before how it builds and how it matures and how it dissipates. But this is one of the most severe weather events that you can find in our location, since we're not really as concerned with tornadoes or earthquakes or things of that nature. Thunderstorms are here to do us a bit of damage. So again, this is just a closer look at what these different air clouds look like. There's the altostratus. You can still see the moon or the sun through it. Mackerel sky. Strato. And this can last a long period of time. You won't get much sun. It's cooler, but you're not going to get much rain in it. Let me go back. Okay. Fair weather, we love to see those.
Fred, is there a place, maybe the NOAA site or something where people can get a chart of clouds for identifying them? I always found them just sort of like fascinating to read the descriptions of each.
Yes, they'll be on the NOAA site and a few other sites. As a matter of fact, you know, if they can see it, I'll hold it up. This is onboard weather forecasting. This is actually produced, we have it in the United States Power Squadrons store, but also you can get it from, it's printed by McGraw-Hill and internationalmarine.com. So this would cover a lot of the things that we looked at today. It'll talk about storms, it'll talk about fronts, et cetera, as well as the clouds. So we have a few more things to do, but that would be a good place. Just go online and Google it, and you'll be able to get things right on the site.
Thank you.
Okay, here's our anvil and like. So we have the winds, boating wind because of motion apparent, and the true wind is what we're going to look to. And what we want to do, as many times, is to find out, well, where is that front? And the few different things to consider. Wind shifts. When we have a warm front coming, it's going to shift clockwise. So we'll have an idea through the day, through a period of time, where that wind is going to be veering and turning to. Backing wind is from your low front and again counterclockwise. So where are we? We're going to show as the front goes through, this is the low where it's turning. Okay. Very little happening up north above. Everything is happening south in this case. So we have a warm mass that's coming through, and it's going to try to grow on top of the cold mass. And we'll see, this is where the steady rain is, the nimbo. And as we go further out, we can see it's clearer and clearer. Here is a very low barometer. It's, if you're checking that way, you can see that it's very full with the air and the pressure. And as you go into kinder weather, it rises. So depending on where you are, you're either in rain or it's going to come to see you in a period of time. This is just the opposite. The front comes through, the cold air mass comes through, and it's very dramatic. You can see how the barometric pressure just plummets and then stays steady. And your thunderstorm as the front. So where is our low? This is Bryce Ballott's law. And this is, if you're facing the lower wind, right arm out, the front, the lower pressure will be anywhere from 90 degrees to 120 degrees to your right on land, and about 15 degrees less on open water. Which means that if we're on a boat and we're heading into the wind, we can see where the low is going to be. This is a northwest wind. An easterly, a south, and a southwest. So you will be able to tell what is going to happen to you within the next days. Now, the next step would be to see what is going to happen to you weather-wise. And what we need to do is, again, face the lower wind. And here is the adages. If the wind is crossing from left to right, the weather will deteriorate. You can read that. From right to left to right, improve, parallel, stay the same. So let's see what that looks like. We have our upper wind. Here we have 1, 2. So this is going from left to right. It's going to deteriorate. We're here, and this storm is going to catch us from, and we're looking down this, just the opposite. And if we're parallel to it, things will stay the same. You'll see a veering wind, warm advection, cold advection.
Now, how do you know which is a warm front and a cold front? Is that you get that from your, if you're standing there?
You get that from your weather forecast.
Okay.
All right, it'll identify. I can go back. It'll identify, but it won't necessarily tell you where you are. What we're looking at is where the low is.
Mm-hmm.
So depending on where you are in relation to the low, you are going to be in front of the warm, in the middle, or behind the cold front by knowing where it is in relation to where you are. And that's the idea of identifying.
Okay.
So yes, this is a few different forecasting tips and observations. One of the things that I wanted to bring up, and it relates to what Paul and I were discussing yesterday, 75% of the weather, the moving of the warm air from the equator, the warmth from the equator to the poles, 75% is caused by wind, 25% is caused by ocean currents. So the question yesterday was, does the wind affect the currents, the ocean currents? So we spoke yesterday about tidals in the bays and the like, but now we'll talk to ocean currents. So if we went back early on, we saw that we had trade winds and the like. But once we got off of Florida, what current comes past Bermuda and up the coast and to us, particularly in the summertime? That's the Gulf Stream.
Gulf Stream, yeah.
So the Gulf Stream is very warm. Everything starts from the equator, on the water just as on land. And you'll have different currents that will go up South America, up through the Gulf and up our coast until it collides with cold water that wants to come down to the warm. And that would be, for instance, the Labrador Current. So when the two collide, they stall each other, just the same as we saw the two air masses, the hot and cold, coming together and stopping each other. So we're flying up, we're on our square riggers, we've headed out of Florida, we've come across, and now we've gone far up north that current is turning, and we saw how we could go across the Atlantic. There were both winds and the remnants of the current carrying you across. It's staggered. It can't go up, it can't go down yet until it gets across to the other coast in England and Europe. And now the cold air takes over and it pushes down through the Canary current, which the sailors would follow till they picked up the trade winds. So it was a great question, and they both work in tandem. It's just the same as that convection cell. That hot air from the equator wants to get to the cold air at the poles, and one way or another it's going to do it. And
well, that certainly proves that we're a living system. Well, thank you, Fred. This was really quite a what's the word? A lesson. I can't wait to take the 8-hour course. You think my head is full now?
There is quite a bit to it. I hope you all enjoyed it. I hope you will check our websites out and see what is available. We offer courses, we offer seminars. We'd be glad for you to choose something else that you might want to visit and get together later in the season.
Okay, thank you, Fred. That was a really amazing. If anybody has any questions, they can email to info@eastendseaport.org. I will forward them to Fred, and we will get them answered for you pronto. Thank you again, Fred. This was quite informative. It really shows that we have a living planet, and I was quite amazed by the big swirls, that form. Well, again, thank you very much, everyone. Again, any questions, please forward them. I don't see anybody in the chat right now. In fact, I put my glasses on. I guess that will end our program. Next week we have another program. It'll be a virtual walk on the beach with John Hassafel. I hope I pronounced it right. I've only known him for 20 years. Anyway, please check our website out for changes, and I thank you very much for participating. Good night now.